Welcome to Lecture 7.3, the Substitution Method. We're going to continue solving systems equation with this third type of method to do so. So like the elimination method, it can be used on any system of linear equations. For example, let's solve the system using substitution for x plus y equals 2 and y equals 2x minus 1. I've labeled each of the equations, the first equation with a 1 and the second equation with a 2, because here's our system. What we're going to do is, for substitution method, we're going to solve one of our equations for one of the variables. And then we're going to substitute for what we solve into the other equation. For example, the second equation is already solved for y equals 2x plus 1. Now we're going to take the 2x plus 1, and wherever we see a y in the first equation, we're going to input the 2x minus 1. For the first equation, we now have x plus 2x minus 1 equals 2. We're going to combine like terms, so we have 3x minus 1 equals 2. Add 1 to each side, so now we have 3x equals 3. And solve for x by dividing each side by 3. So x equals 1. Now that we know what x is, we can substitute back in either equation 1 or equation 2 to solve for y. I'm going to go ahead and put it into the first equation. So x plus y equals 2. Substituting 1 for x, I have 1 plus y equals 2. Bring the 1 over, subtract 1 and subtract 1, so y equals 1. So our solution to this system is 1, 1. Let's examine the system 2x minus 3y equals 12, y equals 2x minus 8. Since our second equation is already solved for y, that's a good candidate to replace the y that's in the first equation with what it equals in the second equation. So I'm going to go ahead and wherever I see the y in the first equation, put in 2x minus 8. So my equation becomes 2x minus 3 times the quantity, 2x minus 8, equals 12. I'm going to distribute the 3, and remember there's a negative hanging out here, to both the 2x and the negative 8. That gives me 2x minus 6x plus 24 equals 12. Combine like terms, so I have 2x and a negative 6x, giving me a negative 4x plus 24 equals 12. Subtract 24 from both sides. That will give me negative 4x equals negative 12. Divide each side by negative 4. So negative 4 divided by negative 4 is 1, and negative 12 divided by negative 4 is 3. So x equals 3. Now I can select either of the two original equations to input what x equals to solve for y. This time I'm going to go ahead and put it in the second equation. So y equals 2 times 3 minus 8. 2 times 3 is 6, so y equals 6 minus 8. Therefore, y equals negative 2. So my solution set to this equation is, for this system, is 3, negative 2. It's pretty straightforward when I have one of my equations that's already solved for the variable. But if neither of my equations are solved for the variable, one of them I need to choose to solve for the variable. You can choose which one you want. Usually go for the easier one to solve. For example, 2x minus 3y equals negative 1, and 2x minus 3y equals 4. I'm going to go ahead and set my first equation. I'm going to solve it for x. By doing that, I'm going to add 3y and add 3y to both sides. So I now have x equals 3y minus 1. Now that I know what x equals, I can substitute the 3y minus 1 in the second equation wherever I see an x. So that gives me 2 times the quantity, 3y minus 1, minus 3y equals 4. Distribute the 2, so 2 times 3y is 6y, 2 times negative 1 is negative 2, minus 3y equals 4. Combine like terms. So I have a 6y and a negative 3y. That gives me 3y minus 2 equals 4. Add 2 to both sides. I'm isolating my variable. 3y equals 6. Divide each side by 3 to solve for y. So y equals 2. Now that I know what y equals, I'm going to go ahead and if I trust that I did solve for x properly, I can just input it into this second equation. Technically, you should always go back to your original equations, but if you're pretty sure that you did solve for one of your variables correctly, I can just go ahead and input what I've solved for y into x equals 3y minus 1. So x equals 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 is 5. So my solution set is 5, 2. Now we've gone over 3 methods to solving systems of linear equation. The first one was graphing, second was elimination, and the third now is substitution. I need to take a step back and talk about solving the system of linear equations by the elimination method. And there are several steps, and some of them are very similar to the substitution. But let's go over these one by one. Step 1 is to decide, this is for elimination method, decide which variable you want to eliminate. Then you're going to use the multiplication property of equality on each side of the equation to separately make the coefficients of the variable that is to be eliminated opposites. Remember, that was if I had a 2 in front of the x and the second was a 1. If I multiply the second one by negative 2, then I can eliminate the x's. Third is to add the respective left and right sides of the system together, solve for the remaining variable, that's step 4, and then I'm going to substitute back in to what the value of the variable that I found in step 4 back into one of the original equations containing both variables so I can solve for the second variable. And then of course you want to check your answer if necessary. So very similar in essence to our systems of solving our systems of linear equations by substitution. But this time I'm just going to solve. I'm not going to worry about the value of one or the other variable. I'm just going to solve for it. And then I'm going to substitute it back into the expression that we found, back into the other equation. Now if you forget, let's say you have two equations, one labeled number 1 and the other labeled 2. You solve the second one for the variable and you plug it back into the second one, you're just going to get 0. 0 across the board because it's going to equal itself. So you do want to make sure that you plug it into, if you solve for 2, the second equation, then you plug that back into 1. Likewise, if you solved for the variable in 1, you need to plug it back into the second equation. Step 3 is to substitute what you received, your solution you found in step 2, into one of the original equations to solve for the other variable. And then, of course, check your results. So here is a system, negative 2x plus 4y equals 14, and negative 3x plus y equals 6. For my second equation, it looks like it's easier to solve for y, so I'm going to go ahead and solve for y, and that would be y equals 3x plus 6. Now that I know what y is, I can plug y equals 3x plus 6 into the first equation, wherever y is. So I have negative 2x plus 4 times the quantity, 3x plus 6 equals 14. Distribute the 4 across. So I have negative 2x plus 12x plus 24 equals 14. Combine like terms. 10x plus 24 equals 14. Subtract 24 from each side, leaving me with 10x equals negative 10. And finally, divide each side by 10, x equals negative 1. Now that I've found what x is, I'm going to plug it back into one of my original equations to solve for y. So negative 3x plus y equals 6. I'm going to plug in negative 1 wherever I see an x, so negative 3 times negative 1 plus y equals 6. 3 plus y equals 6. Subtract 3 from each side, so y equals 3. So my solution set is -1, 3. Just like the elimination method, we do have two very special situations. That's when 0 equals a number other than itself, and then a number equals the same number. For example, 4x plus 2y equals 8, y equals -2x plus 4. If I plug in, substitute my value of y into the first equation, I'll let you run through that, I'm going to get 8 equals 8. Ultimately, when you do all the math, you get 8 equals 8. And you have to ask yourself, when does 8 equal 8? Well, 8 equals 8 all the time. It's a true statement. Therefore, you know that these lines are exactly the same line. They sit on top of one another. They coincide. So your solution set is any point on the line that satisfies the system, which means you can pick anything. Pick 0 for x, and then y is going to be 4. So 0, 4 is a solution. And then you find another point that lies on the line. You find another point. Every single point on the line that satisfies the system is a solution for this entire system. You might be asking, when would I ever use systems of equations? Well, I can set up a system of equations and solve for a point in time where two related things equal one another. For example, let's say we have a cell phone and our plan, we have a choice of two plans. The first plan has a flat rate of $15, and then every minute that you chit-chat, it's $1.50. The second plan costs $24.95, and then for every minute you chit-chat, it's 75 cents. I want to know which plan is better for me. You might think the $24.95 costs more than the $15. But let's see. How do we figure that out? Let's say that y is the total cost of our plan and x is the minutes that we chit-chat. So I know the total cost of our plan is going to be $150 for plan 1, $150 times the number of minutes I chit-chat plus $15. Likewise, plan B, the total cost is going to be 75 cents times the number of minutes I talk plus $24.95. Oh, well, this is a system. And I can substitute in what y is with one of the other equation, with the second equation. So when y equals 0.75x plus 24.95, that's the point that they equal each other. And if I solve for that, the number of minutes at the point that they equal one another is 13.27 minutes. But keep in mind, a phone company is not going to charge you for the 0.27. It's going to bump it to 14 minutes. So how does that help me? Well, here's how it helps me. For plan 1, at 13 minutes, if I plug in 13, it's going to cost me $34.50. For plan 2, it's going to cost me $34.70. At 14 minutes, plan 1 will cost me $36, and plan 2 will cost me $35.45. Now, if I choose, if you think about it, if I'm only going to talk 10 minutes, then plan 1 is less expensive. But if I'm going to talk over 13 minutes, then plan 2 is the better bargain. So that's how we would use system of equations in real world. Now, maybe you wouldn't go through all of this setting up math, but now that you know how to do it, you can solve for the exact minute that maybe a plan like this, plan 1 becomes the better deal or plan 2 becomes the better deal. So that's it for this video. Until next time, be seeing you.